Hi everyone. Um, Today I'm going to be doing a paper 2 theory for physics. Let's take a look. So from a 2019 paper. Okay, I'm just going to set this to scroll. There we go. Interesting. Um, First question. There's no atmosphere on the moon. An astronaut on the moon drops a feather and a hammer from the same height at the same time. They both accelerate downwards at 1.6 meters a second squared, and they hit the ground at the same time. The weight of the hammer is much larger than that of a feather. Explain, in terms of their weights and masses, why their acceleration are equal. Okay, once again, I'd like to encourage you to not just look at this video before you've tried it all yourself. So give it a shot first with your eye. Now, because if you just watch this video without giving it a try, it's all going to seem very easy and very simple with me giving all the answers. But that's not a true reflection, maybe, of where you are right now. So it's not very useful. Am I just actually closing the window? Yes. Thanks, man. So, if I was to drop a feather and a hammer on the moon, they would both hit the ground at the same time. In terms of their weights and masses, well, maybe we can, I don't actually know how weight and mass is going to enter into it. I know that weight is a force and is given by mass times acceleration. So we can say, yeah, I'm going to write here, weight is a force given by F equals to m times a. You know, the easiest answer to this is quite simply, in the absence of air resistance, they will both accelerate. Let me see if I can keep writing here. Meters per second squared. They do mention that the weight of the hammer is larger than that of the feather. Okay. It's kind of backwards logic. But, you know, even though the weight of the hammer is more than the feather, centered. Their accelerations are equal to a. You know, you can actually reason this out, because the force which they experience is given by force equals to ma. And then the acceleration which they experience is equal to A equals to F over M. End of the day, because let's say this is because their mass correlates with their weight, meaning that the acceleration is the same. So this is why a heavy object and a light object fall at the same rate. A fact that was discovered by Galileo. Finally, I'm just going to mention that maybe I should say that with air resistance, one would fall faster. I'm going to actually leave it at that. It's going to be interesting to see what the memo says. Both the feather and the hammer take 1.5 seconds to fall to the ground from rest. Calculate their speed. Okay, so there are several equations of motion that we can use. One of the easiest ones is, it goes as follows. Sick. It goes as follows. V equals to U plus AT. Okay, where V is your final speed and U is your initial speed. Okay, and we've got the initial speed is 0, and the acceleration okay, so V equals to 0 plus acceleration of 1.6 meters per second squared times by 1.5 seconds. So that's A times T. And what's 1.6 times by 1.5? 2.4. Okay. Okay. Oh no, that's if you add them. Command Shift T there. Command Shift T is what I thought. So 2.4 meters a second squared. This is really annoying. Or maybe it's control. So they both hit the ground at 2.4 meters a second. Now we're going to draw a speed time graph. Essentially, it's going to be a straight line graph. You might think, isn't it a curved graph? No, it's not. It's a straight line graph. When you fall and you accelerate, accelerating means you're gaining speed all the time. You do gain speed in a linear fashion like this. The distance will curve upwards, but the speed of an accelerating thing is a straight line going up. And so essentially this goodness, this software sure I'm going to get better software one day. Is basically that height there will now be 2.4. So there's my completed graph. Nice. Now, using the speed time graph, determine the height from which the objects are dropped. That's interesting. Okay, so how do we get height or distance from a speed time graph? Remember that it's basically the area under this graph. So if you had to shade the area under this triangle, okay, area of a triangle is half base times height. The base is a length of 1.5. Height is 2.5. So it's 1.5 times 2.4 times a half. Okay, I'm just gonna time. Good Lord. And that'll turn out to be 1.8 meters, which actually would be probably about a head level of an astronaut, isn't it? How tall is an astronaut? Every time I'm going to do this is crazy, man. Let's see if we can do a shortcut. Nice. 1.8 meters. 3 out of 3, or 2 out of 2. Next question. A student uses a pump to inflate a bicycle tire. So here's a picture of it. Okay. The pressure of the trapped air in the pump is so much. Cross-sectional area is this much. Calculate the force. Right, how are we going to do that? Well, definition of pressure is force times area. Okay, so what's force equal to? Well, if we were to solve that, we'd say force equals to pressure over area. Cool, so force equals to that divided by the other one. And here's a good way to figure this out. Just use Google. So I'm going to type this to Google. Bam. And Google tells me the answer is so much. I'm going to trust that. 6.23. 6.23 what? What's a unit of force, Kieran? Newtons. Yeah, 6.23 newtons. Sweet. Okay. The student pushes the handle to the right and the piston forces the trapped air into the tire. The force exerted by the student is less than that value. Suggest one reason why. Previously they said it was trapped. The air was trapped. So you know when you've got a tire pump and the air is trapped, the pressure will build up inside. But once it's able to pump into the tire, it's no longer trapped inside the pump. Yeah, it's able to flow. So let's say that the air is now able to flow into the tire, possibly with less pressure. It is no longer trapped. How about that? Seems decent. Now, I don't know if you guys have noticed this. Let me see here. Wait, the temperature remains constant. All right. In terms of molecules, why does the pressure increase when its volume is decreased? So, essentially, when the volume of the container is decreased, the molecules have a smaller distance to travel. Meaning they can bump into the sides more frequently. Since there are now more collisions,
which allows the wheel itself, the tire itself, to stay upright without getting any of the air out.
maybe I should have mentioned that first, that the pressure is created by momentum. Important thing to mention is they have a shorter distance to travel, so they can bump into the sides more frequently, so more collisions. More collisions means higher pressure, right?
How many questions are there? Like pages?
Quite a lot. We're on page 5 of 20.
Are you going to do all 20?
I think so.
Maybe you should do 10 and then do another 10 in the next video.
Okay. Maybe I should. Yeah, that's not a bad idea. I'll think about it. Describe how energy is produced inside the sun. The energy. Goodness, this is really annoying. Not ideal software. In the sun is produced by nuclear fusion. Hydrogen atoms are fused into helium atoms, which gives off a tremendous amount of energy. Fusion, the best form of energy. Instead, how this energy is transferred to Earth? Well, it's with waves, but it's a vacuum between us and the sun. So what kind of wave can travel through a vacuum? It's also the waves which give us light. Electromagnetic, I'm going to write it out, radiation carries the energy to Earth, aka light. But I don't just say light, because light implies visible light. It's more than that. There's UV, infrared, X-rays, all that stuff. Yeah. Next question. Explain why solar panels are usually black. Well, black is a color that absorbs light. And
We're actually learning this in natural sciences and technology at high school.
if it weren't black, that implies that some of the light's reflected, not absorbed. Black is the color which absorbs the most light. Okay. So these questions came up in the multiple choice, which is nice. In many countries, solid salts produced by trapping seawater in a large shallow pond and letting the water evaporate. So, how does evaporation differ from boiling? Thankfully, I did the previous test, so I know the answers to this. The first answer is that evaporation can occur at any temperature. Not just any temperature, but let's say a range of temperatures. It's not going to happen at a freezing point. Whereas boiling takes place at a fixed temperature, which is always called the boiling point. Okay. Water on a boiling stove is always at 100 degrees. Guaranteed. It's boiling. The second one is evaporation. Evaporation takes place at the surface, whereas boiling takes place throughout the liquid. Those are the two things. Okay, describe in terms of water molecules what's happening as the water evaporates. Okay. The water molecules are moving at random speeds. It's a random distribution of speeds. I don't know if I should say random distribution, but with some moving faster than others. Okay, with some atoms moving faster than others. So what happens is, at the surface, those molecules with enough energy. So in other words, some molecules have got high energy. Those ones will break their bonds and escape to form a gas. Become a gas. Let me see how that answer looks. State why the ponds used have a large surface area. Well, the larger surface area, the greater the rate of evaporation. So it's to make it evaporate faster. That's obviously what we want. State why this method doesn't work well in a country with a cold climate. The higher the temperature, the higher the rate of evaporation. Sweet. Page 7. Both sound and ultrasound are longitudinal waves. So what do you mean by longitudinal? Well, you get longitudinal waves and you get transverse waves. It's got to do with the way they vibrate. A transverse wave vibrates at right angles to its direction of motion, and a longitudinal wave vibrates parallel to its direction of motion. So I'm just going to say a longitudinal wave vibrates parallel to its direction of motion. I mean, 2 marks. I put in that second phrase to get the 2 marks. I'll see how the 2 marks come up. I don't know if we should maybe mention that it's back and forth vibration. back and forth. Cool. Yeah, you get an ultrasonic bath, which you can use to clean jewelry. So let's see here. The jewelry is lowered into the fluid, and ultrasonic waves of frequency 42,000 hertz produced in the fluid. Speed of ultrasound is so much. Calculate the wavelength. Well, V equals to lambda times F. So I'm going to have to insert the character lambda. Symbols. So first I can search for these damn symbols. These things. I need lambda. Get some lambda Unicode. Okay. Wavelength is lambda, so lambda equals V over there. Right? So, okay, let me just think about that. Right, that sounds about correct. Now, the speed is 1500. Frequency is 42,000. So 1500 over 42,000. We'll use a calculator for that again. Okay, and we come to 0.036 meters. 0.036 meters. Cool. Describe how the ultrasound cleans the jewelry. Well, we did say that. Yeah, this is vibration, right?
Yeah.
We did mention the vibration is a back and forth vibration. It creates back and forth vibrations, which, how does it clean it? How do the vibrations clean it?
Does it not disturb the dirt?
Nice. Disturbs the dirt. I like it.
Disturbs the dirt. Which is what I think is the only thing that is not part of the jewelry.
I mean, it's a very quick answer for 2 marks. We'll have to see once again what the memo is. I think that I am going to stop halfway and we'll check the memo and do the other half another day. Alright. Electric circuit, it's got a 700 ohm resistor and it's got a light dependent resistor. Okay, EMF is 12 volts. Interesting. So, this oscilloscope is like a fancy voltmeter. It's
like a microwave.
Every square up is 2 volts. And every square across is 50 milliseconds. So, if I had a wave coming past every 50 milliseconds, I'd have a little wave in each square.
It would be 5 seconds.
Alright, let's see here.
One way across.
Switch is closed and the trace moves to the position by line P. Okay, so it was at Q, now it's at P. So it jumped from 0 volts to 4 volts. Okay, because it's 2 volts per division. So that's 4 volts, right? So 4 volts. 4 volts. Resistance, okay, well, all I've got for us there is resistance equals voltage over current, alright? What was the current? Did they tell us what the current was? Okay. Right.
What is the current?
For 4 of the volts, yeah, we're not actually going to solve the current. We're going to do it a different way. Maybe we should solve for the current.
Give it a try. And if
The thing is, to get the current, I need the total resistance. And they're asking me for the resistance.
and you need the current for the resistance.
So I'm going to have a different approach, okay? What I'm going to do. This was taking 4 of the volts, alright?
Yeah.
Hence, the LDR is taking the other 8 volts. Okay,
Yeah.
it's in series. So in a series circuit, you divide up the voltage. So since this one is taking 4 volts, this one is taking 8 volts. And here's another thing. The voltage is proportional to the resistance. So it's going to be double the resistance because it was double the voltage. So, no, we're not going to use that technique. We're going to say it was double. Okay, look, I'm going to write my whole little argument here.
It's double.
Since the PD potential difference, we put it like that, across the, I can't spell across, the resistor,
Across the time is 5 seconds.
remaining, remaining.
8 volts.
And since resistance
They also have a video against of what is being shown, right?
Huh?
They also have a video of what's being shown on the screen, right?
Yeah.
So there's 2 videos going on, one against the screen and one with you.
That's right. Yeah, it's going to have
They'll
my
be able
face
to
in the corner and the screen.
Oh,
So,
like
you know,
a YouTube video.
basically, it is proportional directly proportional to the voltage of the
How many marks is for this?
3.
Wow.
The resistance would be 1400 ohms.
U plus O3 A9.
Okay. I mean, if they still don't get it, I'm going to say the voltage was, or the PD was doubled. So the resistance is also doubled. Okay, so the resistance was 1400 ohms. 1400 ohms. Now, the intensity of the light is going to increase. Now,
The intensity of the light incident on the LDR gradually increases.
yes,
State and explain how the trace on the
oscilloscope.
oscilloscope screen moves.
So basically, okay, as far as I remember, with an LDR, when you shine light on it, its resistance goes down. Okay,
Okay.
so because the resistance will go down, essentially the voltage here will go down.
And then there'll be more that.
There'll be more volts on the oscilloscope. Yeah. So the trace on the oscilloscope will go up. I'm going to explain that.
In 3 different ways.
Well, for 3 marks, yeah, for 3 marks. So we're going to say, for 1 mark, I think we're going to say, since there is more light shining on the LDR, the resistance decreases. Cool.
1 mark.
And then
Since the resistance.
they're never going to let me join the resistance because I can't spell resistance. Goes down, the voltage on the LDR. Oh, you're not supposed to say voltage, you're supposed to say PD, potential difference.
Stupid keyboard. Therefore, the PD across
The resistor will increase. So the trace will go up.
Congratulations. 1 more page left for now. Wow.
We're going to do 1 more page.
And then, sorry for you guys, we'll do the rest later. Bye.
We'll do the rest tomorrow or something. Okay, let's see it.
Yeah, you gotta wait a whole 24 hours.
I don't think they can see you. But
A
okay.
whole 24 hours.
Figure 7.1 shows horizontal rectangular coil. Okay, placed in between magnetic field. There's current in the coil. This is the motor rule, and the motor rule uses the left hand. Goodness, I haven't studied this. Left hand rule, your which one is which now? I think your index finger points in direction of magnetic field. Okay. You then point your middle finger in direction of the current. And then there'll be a force. So this magnetic field.
I think it'll go this way, upwards. Something like that.
Yeah. Alright. Explain why there's a force. Okay, because
there's a current in AB, which is perpendicular to the magnetic field.
Alright. Now for the direction of the current. Well, pointing your left hand along north-south, force upwards, is actually giving me a current heading from B to A. So we'll just use left hand rule.
Using left hand rule with the magnetic field given
Let's say with
with the index finger pointing in the direction of the magnetic field, and the thumb pointing in the direction of the force.
The current is going to be given by your middle finger.
So in this way, the middle finger is much more useful.
One of the few uses of a middle finger, which points from B to A. Okay. Determine the moment. Wow. Moment is given by force times distance, guys.
I think the cat's trying to eat the window. Moment equals to force times distance from
Now,
axis.
force, unit of force is Newton. And the unit of distance is meter. So we're simply going to say it is 9.6 times 10 to the power of minus 3 newtons times by 0.025 meters. And you put that in your calculator and you get the moment. I'm not going to actually do the computation, you know?
Yeah.
It's up to you guys to do that. Check out the answer now. Now this is a DC motor. State the name of the device that connects the coil of a DC motor to electricity supply. So what do we put here in a DC motor? We put a split ring commutator. Okay. State one change to the arrangement that's going to produce a greater turning effect. Guys, there are three things that could give this. Greater current, more turns in the coil, or stronger magnetic field. Any one of these will get you the mark. Just name one of them.
I think the stronger magnetic field works best.
Yeah, the coils works good too. More turns in the coil makes it stronger. Okay, now it's time to check out the solutions. How about that? Let's check out the solutions. When we've checked out the solutions, then maybe do another one. We'll do the rest of it tomorrow. Okay, so here we go with the solutions. Cool. So indeed, weight is proportional to mass. W equals mg. Or you could have said F equals ma. The same thing. A larger force acts on the more massive body, but the mass cancels, or the force, larger bodies have got more force putting them down, they've got more weight. They also have more mass. These two things cancel each other out.
And make it like in a way you could say it makes an anti.
Yeah. Force is pressure times area. Hey, I messed that one up.
Force equals pressure times area.
Here, I messed that one up.
Force equals area.
Yeah, I messed it up because...
No, you did it right. Force equals pressure plus area.
No. Pressure is force over area.
Yeah.
So, now it's more correct.
Yeah.
And the correct answer is in fact 230 newtons. Jeepers, I messed that one up big time.
It's a 2.30.
Okay. So, You had to say something. Force on either side of piston due to air/atmospheric pressure or air pressure of trapped air decreases as the valve opens and the air enters the tire. So there's less pressure in the tire, there's less force. And here we see we got this one right. Just gonna have to say molecules collide with the walls. Number of molecules per unit volume increases. Yeah. More collisions. Yeah. They are more dense. They also have the shorter distance to travel. Both are valid. Remember, when things are more dense, they have a shorter distance to travel. Nuclear fusion. Cool. Got that one right. Okay. I said into electromagnetic radiation. Oh. All of these things are electromagnetic radiation. Actually, all of those carry heat. Only occurs at the surface, occurs at any temperature, produces cooling. Interesting. Molecules escape from like the liquid. The ones with the high energy escape. Aha. When you have a longitudinal wave, it's a series of compressions and rarefactions. I didn't mention that, so I only got 1 out of 2 for this one. The dirt gets shaken off. That's funny.
I was right.
You were right. Sick. You did pretty well. Oh, you know what's another way we could have gotten a stronger motor? By using a soft iron core.
Oh my god.
Because
That is so obvious.
it is pretty obvious, eh?
Why didn't you get that?
I sometimes forget all the things.
Yeah, but I mean, like, you have to think of 5 other things, and then you can do that one thing, and then you forget how to write it.
Well, I only had to mention 1 of 3 or 4 possible ways, so I still got 3 out of them. Okay, guys, I'm going to stop that for today. Be back tomorrow with more physics, more chemistry, and everything else that you need to prepare for your exam.
Are free for the rest of the day.
Cheers.
Bye bye.